Welcome to the Everything Building Envelope podcast. On this show, we discuss topics relating to the exterior building envelope, such as waterproofing, glazing, cladding, roofing, and more. You can subscribe to this podcast on iTunes and Stitcher. For previous episodes, show notes, and bonus video content, check out our website, everythingbuildingenvelope.com. Now, here's your host for the Everything Building Envelope podcast.
Welcome to the Everything Building Envelope podcast. My name is Derek Siegel. I'm a building envelope consultant with GCI. I'm excited about today's topic, which is forensic meteorology. And I'd like to take a moment to welcome Rocco Colaci with LRC Services. Welcome, Rocco.
Thank you very much, Derek.
For our guests, Rocco, and our listeners, would you spend a couple minutes telling us a little bit about your history, your training, and how you landed up as the head of top-notch forensic meteorology organization?
Sure. I had a 20-year career in the United States Air Force as a meteorologist, and I was fortunate enough also to be an instructor of meteorology for the Department of Defense. And in those 20 years, I worked at multiple high-profile locations. And near the end of my career, my retirement, I was fortunate enough to be the manager of the largest military weather station at Eglin Air Force Base, Florida. After my retirement, I got heavily involved in the development of NEXRAD, which is the National Weather Service radar, that nice colorful one you see on television. Helped set up a couple of companies across the United States. I started LRC Services in 2006, and here I am today.
Thanks. That sounds good. LRC, so forensic meteorology. For us lay people, what do you folks do? I mean, what are some of the services that you provide, and who are your primary customers? Is it just storm people that are in the storm industry, or what are some of the different areas that you provide services in?
LRC Services provides a variety of products to a wide range of clients. We do forensic meteorology, which is basically an after-the-fact reconstruction of weather events for storms, hurricanes, tornadoes, and such. But we also do site-specific forecasting for a wide range of clients. For example, I do site-specific forecasting for parts of South America, China, Africa, the Gulf of Mexico, and across the United States. We also do data research, and we issue a daily weather newsletter that provides a weather outlook for the next 2 to 3 weeks to 8 to 10,000 people and businesses, including the federal government, each day, Monday through Friday.
Wow. That sounds like a lot of different areas that you work for and a lot of different customers. I know, GCI is a forensic expert that does a lot of work in the storm arena. How are you able to reconstruct some of these events? Do you rely on a lot of your training, or is there scientific data, or what are the different resources you use to put, I guess it's like looking into a crime. How do you recreate these things? Do you look at facts? Do you look at evidence? How do you go about it?
I'm fortunate enough to have a lot of tools. One, I have access to a number of federal weather databases. These are free to the public, so I can dig into weather that occurred as far back as 1980 across the United States, so I can find out weather events, what time something happened, the location it happened, who reported it. There's also another tool that tells me all the different types of weather elements, such as tornadoes, hail, severe thunderstorms, when they occurred every 4 to 5 minutes across any given point in the United States. I have surface observations that are taken at airports and by other agencies, and we also have, again, an extensive background and repository of weather radar for the entire United States going back about 25 years, so I can pinpoint what happened over a site-specific address, let's say your house, every 4 minutes.
Wow. So are you saying that what happens at my house does it vary from house to house or location to location? And how does a property's location influence what's going to happen? Isn't it easy to assume that if there's a storm at my house, the same thing is going to happen 2 blocks away? Or how does that work?
Well, everything is broken down into different scales, from micro scale to what we call synoptic scale, which is very large. But we all know that weather is different from block to block, as you pointed out. So some of the other things we do to differentiate is we make site visits. We go to a location and we see what's the surrounding environment. For example, is a building surrounded by taller buildings, or is it surrounded by flat land, which would allow the wind to blow unobstructed? Are there trees nearby? Is there a higher elevation? Is there nearby water that might have a maritime effect? There's a lot of different factors. So just because the wind is hitting your building one way, 2 blocks over, because of the configuration of the building and the surrounding environment, the wind could affect that building totally differently.
Interesting. I know we had a conversation some time back, and I'd like to, bring this up because I know this is fascinating for a lot of our listeners. You basically provide services. Am I correct in saying all across the world, or for other regions and continents?
Oh, that's correct.
So I think you told me a story about a barge or something that you had to help a shipping company or someone prepare for a journey. Tell us a little bit about that, because I think that's pretty interesting.
Yeah, I have a lot of examples for that, but the one we were mentioning is I had a client that needed to get a large barge from the western end of the Amazon River all the way out to the Atlantic Ocean, and it was going to take about 7 to 8 days. So I had to provide a weather forecast broken down into 6 to 8 hour increments for the entire journey. To do that, I had to have access to a variety of weather satellite information over the Amazon basin, surface observations from Brazil, radar observations from Brazil, and information on the climatology of the area. And it took me several days to gather up all my references and sources so I could then come up with a forecast. And we monitored the weather in real time so that if we need to make a slight change to the forecast, we were able to do that. And luckily, we were able to make have the barge go the entire 8 day trip without any occurrence of unexpected weather.
Wow. That sounds adventurous. That sounds really good and very valuable to obviously that client. We also, for our people listening and perhaps people that are not as technologically advanced as you are, to me, is wind just wind? Is there directional wind? Are there different winds out there, or is wind just wind? Maybe tell us a little bit about that.
Well, to the average layman, wind is just wind, but to a meteorologist, wind is just an umbrella for a variety of subcategories. For example, we have what's called pressure gradient wind. That's what drives most of the wind across the globe, and that's the differences in the temperature differences and pressure differences across the globe. As you see on a map, you see a high and a low, a frontal situation, and those are helping to initiate winds. Then we have what we call thunderstorm winds. These are winds generated by thunderstorms and caused by thunderstorms. Then we have what's called a wind gust. That's a 3 to 5 second sudden burst of wind speed. Then we have what we call a microburst. That's when a storm totally collapses and the winds come down from the upper atmosphere, hit the ground, and spread out almost as if a bomb had hit the ground.
Wow.
We have winds associated with hurricanes. We have a variety of winds. Same with any weather element.
So, and these can be different in intensities, or is a microburst similar to a tornado? Or I've heard the term mesocyclone. I love that word because it really helps me with my elocution. But is a microburst the same as a mesocyclone, or what is a mesocyclone?
A mesocyclone is a large rotating cluster of storms. It can be one large storm, let's say 6 to 8 miles across, or it could be a cluster of storms, all rotating. Now, within the mesocyclone, a mesocyclone can then produce large hail, can produce localized heavy winds, let's say 55 miles an hour or greater. It can produce a microburst. It could produce a tornado. It could produce heavy rain. Think of it as a massive storm. A microburst, like as I said, though, originates in the individual storm cell, where the storm cell collapses from the top down. And as the mass of the storm rushes to the ground, it picks up speed and wind. And when it hits the ground, as I said, it spreads out as if almost like a bomb blast.
Wow. Is that so? That's like has the same effect as a tornado, or what is that? The same power?
It has the same power, but with a different effect. A tornado is vertical and with a lot of shear over a short distance, whereas a microburst creates what we call a horizontal vortex or a horizontal tornado, so that when it hits the ground, you have this, it's like a large barrel rolling across the ground and, affecting everything it hit.
Wow, that sounds pretty dramatic. I'm sure we've had them around Florida, and, Hurricane Michael was just up in the Panhandle, and those folks got really hurt up there. And I happened to be up there. I've had 2 or 3 trips up there, and some of the damage I saw up there is heart-wrenching. It was just very disturbing, and I know they're struggling to get back on their feet. I wanted to ask you, because this is something that I'm very interested in, and I'm sure our listeners are as well. Historical weather, that's been going on, I think the last 2-3 years was very dramatic. We had Harvey in Texas, 50-plus inches of rain. We had Maria that hit Puerto Rico and Florida. We also had Matthew. We had Irma, and we had Michael. What is going on? I mean, it seems like things are really getting more intense and more frequent. What is, as an expert, what can you tell us what's going on, what has happened, and what we can expect?
If you look at the records, the hottest 10 years on record have all occurred over the last 25 years. Water temperatures continue to warm. We're retaining a lot more heat in the atmosphere as the polar ice caps start to melt. That puts more moisture into the air. And as you have more moisture and warmth, that adds fuel to the atmosphere. And as a result, as anything, the more fuel you have, the more explosive results you can have, which is why we see things like Irma, Michael, and Harvey. All of those were Category 4 storms. And we haven't had that many Category 4 storms in such a short period of time, ever in the last 50 years. So I would expect hurricane intensity, storm intensities to continue to remain high for at least the next 2 to 3 years until we enter into a possible less active cycle.
Downturn. Yeah, and I guess that's exacerbated by the fact that the population keeps growing. People are continuously moving closer and moving towards the coastal areas, which obviously are more prone to catastrophic, impacts. And also we're changing the topography of the land. I mean, you look at a city like Houston, and they have a bayou drainage type system where they're moving the water all the way from the top of the city synthetically, because obviously that's not the natural drainage pattern, and it's just flooding neighborhoods left and right because of the massive population and the way that we've tried to steer water away from residential areas. It's not a good combination. Let's just put it that way. I think I asked you, do you think I should start building an ark?
Well, an ark may be a little premature, unless you live maybe up in the Kentucky, Tennessee area. They're getting a lot of rain lately.
Really?
But I would We have rising sea levels. In fact, Miami, as you mentioned, there are some areas where the sea level is so high, a little bit of rain or a little bit of wind off the ocean causes neighborhoods to flood. And I think this is going to be a continuation of this trend for the foreseeable future. I don't see any turnaround where we're going to, you could say, gain land instead of losing land. For example, in Louisiana, there's a portion of Louisiana, the water rise is so rapid that they lose a football field of land every 2 hours.
Wow. I remember being in New Orleans, and I came out of my hotel and I looked up and the water was actually above the hotel. And I guess when you're living basically almost underwater before there's a flood, that's a scary fact that, you know, things are getting worse, especially for a city like New Orleans or the Gulf Coast, you know, where they've had a lot of this going on. I wanted to ask you, so this phenomenon, these levels that are rising, the extreme weather, the cold, the heat, and the storms, is this just a national phenomenon, or are we seeing these trends across the world in other countries?
It's definitely a global phenomenon. As we're worried here about record cold temperatures or heavy rain, places like Europe over this past winter have had record-breaking snowfall, major floods and droughts in Australia, major droughts in China, record cold in Siberia. So it's definitely, when they say global warming, they definitely mean global effects also.
I mean, maybe you don't know this answer. Are other countries doing anything better than us? Are they more proactive? Or are they, you know, I know Holland has had the windmill or used hydro energy, solar energy. I mean, are we catching up? I know some of the other states like California, Nevada, and Arizona are more active with their solar programs. Is Florida pulling their weight, or are we kind of behind the curve?
Well, it depends on who you ask and what area you're looking for. We have a lot of areas where we have solar panels for, like you say, solar farms, but I'm not aware of any large-scale wind farms, whereas out west you see thousands of acres covered with large windmills. So it's all a variety of where you're at. As far as how we rank with other countries, I'd have to say we're probably in the middle. We have some countries that are more aggressive towards climate control, and we have other countries who don't make any effort at all whatsoever. So I guess it's we're kind of stuck with what everybody else is doing around the world too.
Right, and I guess that's dealing with the consequence as opposed to the cause, because like the medical profession, oftentimes they're giving medication for a condition when they're not dealing with the source of taking down forests and doing stuff like that's creating this climate change. We're just dealing with the consequence and not really addressing the fundamental cause of these problems. I also wanted to ask you, I mean, something that, as you know, throughout the years that's really fascinating for me is the storm chaser thing. I've always wanted to just jump into my car when I hear about a storm and just drive, straight into it. Not really straight in, but at least see it from that perspective. Is this something that have you done this? Are you doing this on an ongoing basis, or have you ever been a storm chaser?
I've chased many storms over my years. I've chased hurricanes along the coastline. I've chased tornadoes in Alabama and Mississippi and Texas and Oklahoma. There are actually commercial companies that will you can sign up for and go out and they'll try to chase a tornado with you. They'll try to locate where a tornado is going to form, and they try to take you out there within a safe distance and let you actually watch the tornado form and dissipate.
Wow. Interesting. So looking into our crystal ball, is there anything any technology coming down the pike in the future that's going to improve or make us better able to have more accurate forecasts or help, the population be better prepared? Is there any newer technology that you've seen in the works out there coming?
Everybody relies on computer models. Now, we can make computer models by having faster computers, but we're not providing better information. And until we can provide better information, more detailed, more routine, and incremental information, our models won't be able to really provide any greater accuracy. And the reason I say that is we can, like right now, we have a weather station, let's say, in Biloxi, and then another one in New Orleans, and another one then in Houston. But a lot of weather happens in between those three locations, and we don't have any real-time information for that. We need more real-time information spread across the United States and the globe to access, then feed that into a computer model, and then we can maybe have greater accuracy. But until we get better information, the models aren't really going to do much.
I recall seeing a program fairly recently about NASA, how much they're doing, and I know it's fascinating. They're actually, I guess, studying, because they have all these global satellites. Obviously, I think they have the best or the widest array of satellites around the world. They're actually studying marine life and ocean currents, and it was fascinating to see how, the ocean, obviously, that takes up more than 70% of our Earth, is related to our weather. Is there any correlation, or how do you, obviously you don't look at, when you're forecasting a weather system, you're not looking at the temperature of the water, are you? Are you using any of that data?
Oh, definitely. You have to know what's happening over the water. As you said, 70% of the Earth is covered by water, so you've got to know what's happening over the water as it starts to move towards land. That's very, very important in places like Japan, the United States, Europe, parts of Africa. You have to be aware of what's happening over the ocean. Like us for hurricane season, we put most of our focus on Africa, because the strongest tropical waves come off of Africa, across the ocean, and head towards the United States. So you definitely have to watch the oceans and water bodies to have a good understanding of what's going to happen on land.
Wow, this has been a really fascinating conversation. I know I've certainly learned a lot, and I'm hopeful that our listeners also are happy with our topic and our guest today. Rocco, if we wanted to get in touch with you, or anyone listening out there wanted to get in touch with LRC, can you give us the information of how we would get in touch with you?
Sure. First, you could always call me, and my phone number is 850-830-8656. I also have a couple of websites. The best one, though, is www.myweathersearch, all one word, myweathersearch.com, and that contains a variety of maps for the United States and other parts of the world, real-time satellite, real-time wind information, radar information. And at the bottom of the website, I have my daily weather newsletter that goes out, as I said earlier, to about 8,000 to 10,000 people. But on the web, I have no idea how many people are reading it there. That's another way of getting a hold of me. I have a tab up on the top, LRC services, where you can click on it and then contact me also.
Great. Well, thanks so much for coming in today. Once again, folks, Derek Siegel here with GCI. You've been listening to our Everything Building Envelope podcast. And once again, on behalf of everyone, and especially myself, I'd like to thank Rocco Colaci for joining me today from LRC Services. Please don't forget to follow us on Facebook, Instagram. Check out our website at gciconsultants.com. And we look forward to bringing you many, many more interesting guests and topics for our Everything Building Envelope podcast series.
Thanks for joining us today. Please subscribe to this podcast on iTunes or Stitcher. For more information on the Everything Building Envelope, previous episodes, show notes, bonus video content, and much more, check out our website, everythingbuildingenvelope.com.